S-Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, as we have done in the previous video about the oscillators, amplifiers, so we can understand that what is the role of the amplifiers in the circuit. So today in this video we will operate with the operational amplifier.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
So welcome to the S-Chan Academy. My name is Kanahaiya Jha. So students, as we have done and studied about the oscillator, that what oscillator do, how it sends a carrier wave, and the carrier wave overlaps the target wave, and we say that the communication is done. Along with that, we have done amplifiers, that in the amplifiers, how the input and the output are related to each other. It means that we say in the amplifiers, if this is the input, so the output is very much higher than the input. So we have discussed this, that how we calculate the particular gain factor. So today we will discuss more in depth into this, and we will discuss more about the integrated circuit 741, which is called as an operational amplifier. We will discuss how it is used, what are the application, what is the circuit configuration and all. So let's start. So operation amplifier and its application. So first we will study about the operational amplifier and its application. So we can see here that this is 741 is IC 741 is called as an operational amplifier circuit. We will study about the IC 741, we will study what is the ideal op-amp, we will study in the coming videos what is the inverting mode, what is the non-inverting mode. Inverting mode in the sense that whatever the input that we give, we get the output in the inverted mode or in the non-inverted mode. We will discuss that how the two inputs are integrated together and we are getting the output, how we are integrating the particular input and we are getting the particular output. So we'll study the integrator and we'll study the differentiator. As the name suggests, differentiator, that whatever the changes in the amplification, the differentiation can calculate that. Okay, then we will study about the stimulation of the circuit. Then operational amplifier we'll study as a RC resonator. RC resonator is again the resistor and the capacitor. We'll study op-amp in a bistable mode, and we'll study the the operation amplifier as a comparator. So in a very summing language, what we need to study today is the integrated circuit IC 741 as a operational amplifier, as differentiator, as adder, as integrator, as stimulator, and then as a comparator. So we'll study all these things one by one. So first is what exactly the IC is. So let's start with the integrated circuit. What integrated circuit is? We have named this circuit as IC 741 and it is used as an operational amplifier. We can use as an analog to digital converter, digital to analog converter, and we can use for the parallel circuits. So analog to digital means what input that you give is the analog, the output that will come is a digital. In the same way, if we give the digital one and we need the analog. So we can use it in both the particular mode. Then we a complete op-amp circuit is realized by combining analog circuit building blocks. So what we have done in the lower classes, that how we study about a PN junction diode, the two junction device. Then the two junction device was used as a three junction for the PNP transistor. How we use the different configuration of a PNP transistor, how we are using the common base configuration, how we are using the common emitter configuration, and how we are calculating the current gain in that. So when we calculate a current gain, especially if you remember when we calculate alpha and beta. So here what we see that a particular integrated circuit is basically made by using the analog components that we study in the lower classes. The bipolar op-amp has a general purpose variety and designed to fit wide range of specification, and the terminal characteristics is nearby ideal. So what we need to learn is that whenever we design a particular circuit, integrated circuit, as the name suggests, many components are integrated over one particular chip. So when many components are integrated, then the components are the analog components. So analog components are basically the diodes and the transistors that we have done. So they are fabricated on a single chip, and then we are getting this. So when we talk about the output may vary from one particular form to another particular form. So as we say that if the output required is a digital or the output required is analog or comparator, so whatever the kind of output that is required in the particular circuit, the particular operational amplifier is able to produce that. We can use this as a integrator, we can use this as a differentiator, we can use as a adding circuit, comparating circuit and all. Then we have the IC4741 as a circuit. So first of all, when we make a circuit, then we have two stage, the input stage and the output stage, and between them there is an intermediate state. Okay, after that there is a biasing circuit and a device parameter. So biasing, we have, when we were learning the PN junction diode, then we have learned that what is the use of biasing. Suppose taking an example of PN junction diode, we give supply to the positive terminal and the N junction to the negative terminal. The diode was in the forward bias, and when it was in the forward bias, it was in the pure conducting circuit. But again, when we have done that in the reverse bias, then the diode was not conducting. So what happens, that biasing is a very important characteristics of the circuit, where it generally defines that the circuit will conduct or it will not conduct, and if it will conduct, then how it will conduct, and what are the various methods that when it will not conduct, what are the calculations that we can do. So biasing mode, that we will study that how we are using this in the biasing mode of this particular circuit. Then what we will learn here in the biasing circuit, that we will take a particular, the way we have taken the transistor. Suppose we have taken a transistor here like this. Let's take an example. So we know that this is the input and this is the output. So depending upon the nature of supply that we give to the input and that we give to the output, we can make the calculation. So let's see that this is the common emitter type. When we give the supply like this, and this is the output, when we give the supply like this, in this case this is the input and this is the output. So the output, the variation in the particular output will be according to the input only. Whatever the input that we have used, the variation in the output according to the input. So when we say alpha, this is the current gain in the common base, beta, current gain in the common emitter. So we have discussed alpha and beta are the two particular characteristics which are used as a current gain. In the same way, when we will design the particular op-amp, we will see that how we make it, how the input and the output are connected to each other. Okay, so how the input and the output are connected to each other, we will discuss the particular design of the particular circuit. If you see here, inverting configuration. Inverting configuration means that whatever the input that we are giving will get the output in the different form, or we can say that we are getting in the out of phase, or we can say that if the input given is something, the output will be in the non-inverting mode. So inverting is generally required. So this particular differentiator is that whenever there are changes happening in the operational amplifier between the input and the output signal, we give the input signal and we want in the output signal, and the changes are occurring in the output signals, and we can easily calculate the changes in the particular output signal. So the input and the output signals are there. Then resonator, as the name says resonance, it works on the resonance frequency, that natural frequency. So the operational amplifier can work on the natural frequency the operational amplifier can work on a particular given or a particular selected frequency. It can work on any particular type of frequency that we have. Then the IC741, the same, we will in the coming videos we will discuss the structure, the circuit and the configuration and the stimulation of the particular circuit. So IC741 as operational amplifier means that when we give a particular input and we want the amplified form of the output. So when we give the particular input and we want the amplified form of the output, then we can make changes in the given input when we need a particular type of output, and that has to be the amplified output. So we use this, we give instruction to the input, we give the instruction to the input of the circuit. Accordingly, we will get the output of the circuit, that will get the the frequency change in the particular output, the wave variation in the output, the oscillation change in the particular output. Accordingly, we will get the changes in the output. So comparator, as a name suggests, we compare the particular two oscillation values, that at what particular frequency the oscillation is happening, and again in the given particular frequency the oscillation is happening. So at a two particular value of the frequency the oscillation is only happening, and we generally calculate the difference in the two particular categories, how the oscillation is generally happening in the particular circuit. So we basically if you see here, we can use, these are terminals that coming videos will discuss and design the particular circuit, that input and the output, and both the input and the output are concerned with the particular biasing. If the biasing is different, we will get a different kind of input and the output. So the biasing plays a major role, either it is inverting or it is a non-inverting. So biasing has a major role. Okay, so in the intermediate stage, in the sense that when you give the particular input, okay, and the output is required at a different particular form. So we use this. So these are the particular stage where the amplifier is generally used. Then we have what we have learned, that what exactly the operational amplifier is, what is the name of this particular integrated circuit. The name is IC741. How the inputs and outputs. So we will discuss in the coming videos how the input and output are generally designed. But in this video, we generally learn that it can be used as an integrator, it can be used as a differentiator, it can be used as an adder, it can be used as a comparator. So all these particular operations that we can do with the operational amplifier. So now we will take a small break, and after the break we will generally see how the circuit looks like, how we make the changes in the particular circuit, and how we calculate input and output from the particular circuit.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back, students. So before the break, what we have learned, that what is the operational amplifier, what all operations that we can do with the amplifier, and the integrated circuit 741, what all operations that we can do. Now we'll further move ahead and we'll discuss that what are the circuits and how the particular circuit is generally designed. So this is the basic circuit where we can see that there is a particular resistance that we are using, and we are using the transistors. I hope the concept of the transistor is very much clear to all of us, that how we are using it. So we are using this particular transistor. This is Q11, then Q12. So two transistors like this, Q1 and Q2, and then it will give the output. In the same way it will give the output, and it will same way it will give the output. So there are stages where we can see that how it is designed. This we have to give this for the minus VCC, and this is for the plus VCC. So here you can see minus 15 volt, and here we can see that it is plus 15 volt. So again coming back, we have discussed that a particular op amp is basically consists of the particular components that we have say small components. So from the diode, we are using the PN junction diode. From particular diode, we make a 3-terminal device, which is a transistor, and see, we are using a particular transistor. We are using a particular transistor here, and we are making a set, and then we are forming a particular IC. So two voltage source are given, the plus VCC and the minus VCC. Two voltage source are given, and from this two particular voltage source will make the particular calculation. So input and output, we can easily see this is input, and then here we can see that this is the output. Here we have used the input resistance, and here we have used the particular load resistance. So whenever we will make a calculation in the lab, we will calculate it from the load resistance, and we'll calculate the input from the input resistance, and we will see that what is the variation. If the variations can be seen in two ways. The first way is that when you make the calculation, we'll find that the value of the input is less and the value of the output is high. Or when you make the graph, then you can see that the value of the input is, we are getting the lower line in the graph, and the value of the output, we are getting a higher line in the graph. So lower line in the graph and the higher line in the graph will show this, we'll see these two particular variation in the input of the particular circuit. So we have this particular thing designed for the operational amplifier, where anytime we can make the calculation and we can check it. Then we have understand that how many transistors, 24 transistors, few resistors, and only one capacitor to power supply short circuit protection. So we have used 24 transistors, then two power supplies are generally used for calculating the variation between the input and the output, that whenever the variation is happening between the input and the output, then we can calculate it. Short circuit protection, like we have used the input resistor, we have used the load resistor, like this we have used the particular resistors with the particular values, and then we have made the calculations and all. So 24 transistors we have seen in the particular slide how they are generally used. See how the transistors are generally used, and between the transistors how the particular value of the resistance is generally used. So we can see that here the transistor 1 and the transistor 2. Okay, then we proceed further with 3 and 4, and then 5, then 6 and 7, 5, 6 and 7, and then we proceed one set. After making on one set, we'll make another set, and then we'll calculate it for the input and the output. Every time we have to give two ports. The two ports are generally given to make a variation between the input and the output. That whenever we give the positive supply and whenever we give the negative supply, they can be used to calculate the variation between the input and the output. So this circuit we have to understand very carefully. It is not difficult, very easy to make, because we have already learned how to use the particular transistor. So if we have already learned how to use the particular transistor, then we can arrange the transistor in this particular way and we can study further. So we have already discussed this, that how it is consist. Now very important, like the input consists of transistor Q1 through Q7. So if you like there, then the input, if we say input, then the input is through Q1 to Q7 in this particular transistor, Q1 to Q7 in this particular transistor. Then we have Q1 to Q4 is a differential version of the common collector and the common base configuration. Then high input resistance. So we need to understand that Q1 to Q7 is an input, Q1 to Q4 is a differential version, and then Q5 to Q7 is a current source. So input version, then the differential version, and then the current source. So as we say that we have make it a different section, and then we have calculated it. So this is the input version. Here we can see the input. From the input it will go. Okay, then we will make the particular how the amplification will be prepared, and then we will calculate the output. Every time for the circuit protection we are using the input resistance. As a input resistance, the value of the current will be minimized so that the component will remain safe. So whenever the current flow and the high current flow to the input, because of the input resistance which is connected in series, it will get minimized, and then only the control value of the current that will go in the output, and that we will calculate the current in the particular output. So we can see the pin configuration here. So 24 transistors are used. Few resistors, that includes the input resistance, that include the output resistance. Capacitor are generally used in the output, because whenever there are losses in the particular output due to signal failure and the non-propagation of signal, then the capacitors generally do. So the capacitors are also connected in the particular circuit. Power supply has to be given, and it has to be particularly determined that which leg is a positive leg and which leg is a negative leg, and then the protection for the short circuit has to be done using the proper value of the particular resistor. So the input stage here, the input stage is between the Q1 and Q7. As we have seen in the circuit, Q1 and Q7 will give the input to the circuit, and we have given the plus 15 volts supply to the particular circuit that was given to the particular input of the circuit. From Q1 to Q4 is a differential version of the common collector and the common base. So we are using the transistor in the common collector mode, we are using the transistor in the common base mode and the common emitter mode. So in the Q1 and Q2, the differential version, the common collector and the common base mode are generally used. And then the high input resistance. High input resistance is a very important parameter of the operation amplifier, because as the circuit safety is concerned, and if high particular current is flowing, then the current will be blocked and only the required amount of current will go to the output. So what will happen, that the amplification factor will become very high. Let's take a very common example, that when we say the circuit common collector, we say input follower, that it follows the input, because the reason is that when we say the common collector, the collector leg of the transistor has the lowest resistance. So whatever the current that is coming in between when the collector leg is common, then the entire current is generally used. So what will happen is that very few reverse back to the particular input. So we say that the output is very less as compared to the particular input. So this is a very important factor, that it is a high resistance. Then current source from Q1 to Q5 to Q7, there is a current source where we are using the amplification, okay, and it does not provides a high resistance load, but also converts the signal from the differentiator to single ended from with no losses in gain or the common mode rejection ratio. So we will calculate that in the common mode rejection ratio also. Then we have the intermediate stage. The intermediate stage is calculated at the transistors 16, 17 and 13B. We will calculate it. Then common collector configuration is used in the Q16s, give a stage high input resistance and reduces the load effect of the input resistance. Then the common emitter for the Q7 provides a high voltage gain because of the active load, and the capacitor in the common collector introduce the Mylar compensation to ensure that the op amp has a very high unit gain frequency. So here we can see that we are arranging this to calculate the unit gain frequency. So just recalling this particular circuit again. So we can see that in this particular circuit, how the different transistors are generally used and what role the different transistors are generally using. How the transistors are used for the input and the output mode. How the transistors are used as a the current mode. How the transistors are used as a common mode, rejection mode. How the transistors are used, either they are used in the common base, common emitter or the common collector. So depending upon the nature of this, how the transistors are generally used in the different segment and how they are generally vary. So here with the pin configuration, here the particular number allocating that how they are varying from the one form to the another form. We have learned the intermediate stage, how they work in a different intermediate stage, and this is the output stage. The output stage efficient circuit called the AB output stage. Voltage source composed, this is the voltage source 18 and 19 supply, and then at 23 the common collector configuration is used. So short circuit protection circuitry, that we forward bias the R6 and we forward bias the R6 at a transistor 15 and reverse bias R7 at the transistor number 21, 22 and 24. So what will happen is that when we reverse bias this, the current will flow where the current will not flow, and when forward bias the current will flow. So this is the output stage. We can see this is the VCC, and this will give here the particular output. So this is the emitter follower, and this is the class B output stage. Emitter follower is basically called as an input follower. Input follower in the sense that whatever is given in the input, okay, goes in the output. So input follower, we generally say this. So in this video, we conclude that what exactly the operational amplifier is, what is the integrated circuit 741, how we calculate the pin configuration, how we understand this as a comparator, integrator, differentiator. Hope you have enjoyed this video. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.